All right, here we go. It says sketch the graph of y equals x plus 4 and the reflection of the graph in the line y equals x. Then give the equation of that reflected graph. So let's start off by just graphing y equals x4. And so we've got y-intercept of 4, slope of 1, and there's that line. That is y equals x plus 4. Now we're going to reflect that across the line of y equals x. So again, slope of 1, y-intercept of 0 goes through the origin. That is the line y equals x, and so here's y equals x. Here is y equals x plus 4. And so we need to reflect it. Now remember, when you're reflecting across the line of y equals x, you are swapping the x and y values. So if we had y equals x plus 4, we're going to now be switching and getting x equals y plus 4, and solving for y. We're getting the inverse. So that will give us, if we subtract 4 from each side, we'll end up y equals x minus 4. And actually, we'll write that one out in green. Minus 4. Y equals x minus 4. So there's the equation of the reflected graph. Now, how can we reason through that another way other than just simply swapping our x and y values? Let's think of some of the points that are on the line, the original line, the y equals x plus 4. It goes right through the point of 0, 4. And remember, when we're reflecting it over the xy axis, so if we went from the point of 0, 4, and we're going to end up at the point of 4, 0. The x and y values are going to be switched. And hey, look, our graph does go right through the line of 4, 0. This point here has been reflected across the line of y equals x, ending up at 4, 0. Likewise, take the point of, let's say, negative 1, 3. There's another point we can see pretty easily. So get back to the blue again. Negative 1, comma 3. That was our original, the point in the original line, and we're going to swap those x and y values and get 3, comma negative 1, and hey, 3, comma negative 1. There it is, right on our graph. All right, so that is reflecting the line across y equals x. And again, this is how you would find the inverse. Now, the inverse may not always be a function, but graphically, here's how you would go about that. All right, hope that helped.